Hello, we're Team AJAYA, a group of biomedical engineering students from the University of California, Irvine, and we're here to tell you about our low-cost microelectrode array system capable of recording neuronal voltage signals. But first, a quick background. Did you know that neurological disorders are the leading cause of disability in the world, affecting more than 1 billion people? One of the most common neurological disorders and the focus of our research is epilepsy. Epilepsy is a neurological disease that causes a person to have frequent seizures. During a seizure, the brain's normal electrical pattern is disrupted by sudden and synchronized bursts of electrical energy that may briefly affect their consciousness, movements, or sensations. Nearly 52 million people are affected by epilepsy worldwide, and 80% of these people reside in low income regions. A majority of the people living in these regions are speculated to go untreated and undiagnosed due to the lack of affordable, accessible diagnostic options.
Currently, there are three main techniques when diagnosing epilepsy, and this includes a CT scan, MRI, and EEG. However, there are some drawbacks to these techniques. For instance, for a CT scan and MRI, they are very fast and reliable. However, they are very expensive for small clinics. And furthermore, for an EEG, they can be less expensive. However, they are extremely uncomfortable for patient use.
To address these drawbacks, our team has partnered with NeuroDetect to fabricate a low-cost microelectrode array recording device. A microelectrode array, or MEA for short, is a small in vitro device that contains many tiny electrodes that are capable of recording the field potentials of a population of cultured cells. Within the context of epilepsy, this means that the device can be used to measure the electrical activity of cultured neuronal cells, revealing abnormalities such as those shown on the left that can allow experts to form a diagnosis for their patient.
NeuroDetect's MEA recording system emphasizes simplicity, affordability, and modularity by using cost-efficient PLA filament to 3D print housing components and integrating easily accessible electronics. Our two-compartment system allows for high degrees of organization and sterility, while also creating separation between the incubation and signal processing sections of the device. Users must simply culture their cell line onto a NeuroDetect MEA chip, plug it in, and insert it into the incubator. Once powered, our system will begin recording neuronal signals and display both the temperature and carbon dioxide level of the incubation chamber.
Our device is unique when compared to other MEAs as it is cost effective, minimally invasive, and provides strong and reliable connections between the electrodes and the circuitry. We utilize a single well MEA with 64 electrodes, which is effective in our device while still being one of the more cost efficient options. The researchers that will use our device will be able to take a small blood sample from a patient and convert the blood cells to iPSCs that will then be differentiated into neuronal cells to test electrical activity and detect any abnormalities before a seizure has to occur. And finally, to improve the connection between the neuronal cells and the amplifying circuit, we use two PCBs to strengthen the connection between the electrodes and the circuitry. Given these advantages, our novel design for an MEA amplifier is on its way to become the standard procedure for testing for epilepsy.